Welcome in lecture series of electrical installation and practices. Today's topic is lightning arrestor. So this is the different type of lightning arrestors which are used in the substation or electrical installation. This is the copper lightning arrestor. Generally, such type of lightning arrestors are mounted on the topmost part of the building to protect the high-rise building against lightning stroke. And these are the some lightning arrestors are connected or installed in the electrical installation, substation, transmission lines in the system. So what is the electrical lightning arrestor? The lightning arrestor is going to divert the lightning stroke or high value of current safely to the ground and protect the electrical equipment connected with the line. There are many equipments, those are connected on the line like transformer, generator, then circuit breakers, CTPTs, measuring units, then protection systems. These all are very costly and very essential part and backbone of electrical power system. So the lightning strokes are generally occurs, and this lightning strokes has tremendously very high voltage. It is a peak impulse voltage is there and decay with some comparatively long time. So it is quickly occur is the maximum value and reaches to its minimum value. Therefore, the lightning arrestor is going to divert the lightning stroke safely. It consists of spark gap, means there is a gap between the ground and some gaps are provided. So this is the spark gap. It is complete assembly of lightning arrestor. This is the porcelain part, which is similar to the suspension type line insulators. So this is the complete, but it is a complete one. Ceramic coatings are there or ceramic housings are there. In between, this is the porcelain housing. This is terminal, current carrying terminal, means the conductor is connected over here. And the second part is connected to the ground. So this is the ground. So here, this is the ground is connected. So it is somewhat electrical circuit of this lightning arrestor. This is the spark gap, series of spark gaps are there. And it is a non-linear resistance. Non-linear resistance, nothing but resistance which offer high value of insulation resistance at normal voltage, and for the impulse voltage it will provide the low resistance path to divert the lightning stroke safely to the ground. Say it is a 33 kV transmission line, so it will provide a sufficient insulation level for the 33 kV lines. But whenever there is a spark is, or whenever there is a lightning is going to occur, say for the 100 kV, at 100 kV voltage, this offers the low resistance. So therefore, it is called as a non-linear resistance. So this non-linear resistance is connected in series with the spark gap, and it is connected between the line and ground level. So there are different type of lightning arrestors for the different voltage levels are there. Say this is for the 33 kV transmission line. It is 132 kV, 400 kV transmission lines are there. So more this one, this is say 400 kV, 132 kV transmission line, the lightning arrestors are there. It is mounted at the beginning of the circuit, beginning of the substation. So this is, say for example, here we are going to connect a lightning arrestor at the beginning of the circuit beginning of the say substation. So this is called as a lightning arrestors. Now the second part is the isolator. Isolator is a device which is going to operate in off condition or off load condition. Say here isolator is similar to the switch, but there is no means to extinguish the arc. Whenever we are opening the circuit, it will produce the spark, and when there is a spark, therefore at this medium voltage there is no need for the arc quenching media, but for the high voltage there should be some arc quenching media. It may be oil, it may be vacuum, it may be SF6 circuit, SF6 gases are there where the arc can be quenched out, or means the arc can be extinguished very quickly. Otherwise, it will produce the arc and it will make the contact even though by opening the circuit, this one. So the isolator will provide for the physical isolation or physical disconnection of the device in addition to the circuit breaker, but it is going to operate in only off condition. Say here, this is a single line diagram. This consists of, this is incoming line. For this is the incoming section. This line is a oil circuit breaker. So this is the oil circuit breaker. Next is the bus bar. This is bus bar section. This again oil circuit breaker. Transformers are there. This is a star transformer. It may be a star delta transformer. Again, there is a lightning arrestor. So lightning arrestor here, it is going to provide to protect the transformer. Similarly, if you are going to connect the same lightning arrestor at the beginning of the circuit, beginning of the substation or beginning of the line, it is going to use to protect the circuit breaker and all this one. So it will act as a backup and it will act as a primary protection for the lightning arrestor, lightning stroke. So now we are discussing about the isolator now. So isolator is provided, suppose we want to work somewhere here on the bus bar. So therefore it is necessary to open the circuit breaker, but the opening of the circuit breaker or opening of the contact is not visual. So we will provide some visual disconnection of this section. So here one isolator is connected, here one isolator is connected, and it is get open. So by moving this handle, this is the handle and this is the, say, arm. By moving this arm, this handle is going to come here. Similarly, this part of the handle is goes in this direction. So it is just like a opening up. So here double side, or it is a double break isolator symbols are there, where two side opening of the say circuit is there. So it is very much safe as compared to the single arm is there. So it is used for the 33 kV, 132 kV and on so on, so on. So this is circuit breaker. Suppose similarly, by opening this isolator, it is easy to do the maintenance over the circuit breaker, some work over the current transformer. Similarly, one more circuit isolator is there. If it is used to do the maintenance on this circuit breaker. Similarly, one more isolator and circuit breaker is used for the protection for the say maintenance of the transformer. So in this case, there are number of isolators are provided to isolate the section from the live part. So say, suppose if 3' is isolated, the meaning is that this dotted line is not active, only this line is active. Suppose some work is want to work, suppose some maintenance is going to work, maintenance work is going to on this section. Now we will open this circuit breaker, then open the isolators and start work over this one. So this is the way by which we can do the we can use the isolator. But it is very much necessary to operate the isolator only in off condition. So the sequence of operation for the opening of the circuit is first open the circuit breaker. Once the circuit breaker is open, then operate the isolator. But when we are going to charge the line, first close the isolator, one oscillator, second isolator, and then close the circuit breaker. So in this case, opening and charging and discharging condition, the circuit breaker is going to operate first for the opening condition, and circuit breaker is going to make on or close after closing of the isolator. This is the sequence we have to remember. Otherwise, fatal accident or say fault is going to occur. Not fault, is hazards to the human being also. This is 2-arm isolator is there. By moving this handle simultaneously for one phase, second phase and third phase. So once we move the handle, this arm is going to operate and it is going to swing in this direction. Say it is going to swing in this direction and this is going to swing in this direction. So it is going to close. So this is the close position of isolator. This is the middle arm. So this is the middle arm and this is the two contact. So this line, bus bar line, is connected to the second bus bar line. Similarly, in the substation, this is one more isolator is a close position. This isolator is open position. So by opening and closing, done with the help of motorized system, or it may be the handle, some handle operation system. Say this is the handle which is going to use for opening and closing the isolator. Now this handle can be connected with the motorized system. So by remote operation or auto operation, we can do the operation of isolators are there. This is moving arm and this is fixed contact. So this is called as a single arm isolators are there. Now circuit breaker, say this is the single line diagram. This is incoming line. So first of all, the incoming line with the lightning arrestors are there. Then this is the potential transformer for measuring the for the voltage. Then isolator. After isolator, there is a circuit breaker with a current transformer for measurement purposes as well as the protection purpose. This CTPTs is used for measurement as well as the protection devices or different type of relays. Now there is a oil circuit breaker, 11 kV oil circuit breaker, again isolator. So this true isolator is going to use for the maintenance purpose or some routine work over the over this circuit breaker. Now if you close this isolator first and then closing the circuit breaker, the line gets charged. So once the line gets charged, we can operate this transformer for the outgoing purposes. Say if you are closing this isolator and oil circuit breaker, the transformer gets charged and it is possible to give the supply to the load. Similarly, if this line is again closed, the second transformer also is going to transmit the power or transfer the power to the load circuit. So there are two incoming lines. Whenever there is a fault in one of the transmission line, the reliability and continuity of supply can be maintained with the help of double incoming and double outgoing system. So this is the circuit breaker. Circuit breaker is nothing but the to open the contact in the live part, but it is going to operate automatically and in the on condition. Whenever there is a fault is going to occur, the relay going to sense the fault condition. It will give the command to the trip circuit, and trip circuit is going to close the contact of the circuit breaker, which will open the circuit breaker contacts. Means there is a one circuit breaker contacts and tripping circuit is there. Tripping circuit is the control circuit, whereas circuit breaker is going to close and open the power circuit. So this is some different major part of the circuit breaker. This is the moving arc contact. This is moving, then moving main contacts are there. This is the moving, and this is fixed contacts are there. So by using this one, we can close the circuit with the help of this, close the circuit and open the circuit. So what is the difference between isolator and circuit breaker? Isolator is going to work in the off position and circuit breaker is going to work on the load condition. This is one thing is there. Second is that isolator is a air circuit breaker where the quenching media is not there. Whereas for the circuit breaker, there are different insulating material or air quenching medium is used. It may be the vacuum, it may be the oil, it may be the SF6, it may be the say compressed air there. So it is called as a air blast circuit breaker. The name of the circuit breaker is based on the medium used for quench the arc. So SF6 is the negative gases are there. So when the contact open, it will produce the arc. It will absorb the electrons, and therefore arc is get quenched very easily. So above 132 kV SF6 circuit breakers are used, and for the 11 kV, 33 kV, we are using the vacuum circuit breakers for the operation on and off. So these are the different type of circuit breakers are there. This is a oil circuit breaker. This is the tank, and the oil is filled, and your moving contact and fixed contacts are there. Whenever there is a opening of the circuit breakers, it will produce the arc. That arc is going to quench or cool down with the help of oils. Now this is the vacuum circuit breaker. Means in this chamber vacuums are there. So as compared to the size of oil circuit breaker, vacuum circuit breaker is physical size is small, because the contact between moving and fixed contact, the air gap, the gap is very small in the vacuum circuit breaker because vacuum provide the better insulation. This is vacuum circuit breaker again. These are the SF6 circuit breaker. So here, in case of oil or in case of vacuum, the SF6 gas is used. So it is used for the 132 kV and 400 kV and so on. So these are the different type of circuit breakers are used. So thank you for this part of our electrical installation and practices. Next time we will see the instrument transformer. Thank you.